We tend to think of computers as these purely logical machines, right? Everything is black and white, something is either on or off, true or false, a 1 or a 0. But what happens when we try to make a computer understand our world, a world that is, well, it's almost never that simple.
I mean, really think about it for a second. Is the coffee you're drinking hot or not hot? Is a person tall or not tall? Most of the concepts we use every single day, they aren't simple yes or no questions. They live on a spectrum. And that creates a huge and fascinating challenge for artificial intelligence.
And right here, this is the fundamental clash. On one side, you've got the super rigid binary world of a classical computer, where everything is perfectly precise. And on the other, you have our reality, which is just filled with ambiguity, vagueness, and a million different sort-ofs. This is the core mismatch we absolutely have to solve.
So this really brings us to the heart of what we're talking about today. How do we get our technology to move beyond this very simple black and white world of just true or false?
Okay, so here's the bottom line. If we want AI to be genuinely intelligent, to be truly useful in our world, it can't be stuck in that binary mindset. We have to give it the tools to navigate all the messiness of reality, to reason with imperfect information, pretty much exactly like we do all the time.
So, how in the world do we do that? Well, the answer lies in this really powerful idea called many-valued logics. And as we're about to see, it's all about embracing those essential and, frankly, very human shades of gray.
At its core, many-valued logic is pretty much what it sounds like. Instead of being trapped with just two options, true or false, it opens the door to a whole range of values in between. It's a system of logic that's literally designed for nuance.
And this is the absolute perfect analogy. A standard light switch gives you exactly two choices, pitch black or blindingly bright. But a dimmer switch, a dimmer lets you pick any level of light you want along the way. Many-valued logic is that dimmer switch, but for truth.
Now, this isn't some brand new idea that just popped up. While classical Boolean logic has been the bedrock for ages, visionaries back in the early 20th century, like John Lukasiewicz, started building these more flexible systems. They're the ones who really paved the way for the advanced tools that are powering so much of modern AI.
All right, so behind all these logics, there's some pretty serious math going on. The framework that actually makes Lukasiewicz logic tick is a souped-up version of the Boolean algebra we all know. You can think of it as the upgraded rulebook that lets logic play on a whole continuous spectrum instead of just two lonely points.
But hey, let's not get lost in the math here. To bring it back to our analogy, if many-valued logic is the dimmer switch, then this mathematical framework, that's the sophisticated engine inside that makes the whole thing work. It's what allows for that smooth transition from dark to light.
Now, out of this whole family of many-valued logics, one particular approach just exploded in popularity, especially in AI, because it's so intuitive and so practical. It's time for fuzzy logic to take center stage.
So, meet fuzzy logic. Its entire reason for being is to manage the kind of uncertainty and vagueness we humans navigate constantly. This was a total game changer, because it finally let machines handle concepts like it's around 100 degrees or he's driving pretty fast. Ideas that are second nature to us, but completely impossible for rigid binary logic to even touch.
The absolute genius of fuzzy logic, which was pioneered by Lotfi Zadeh, is this concept of linguistic variables. This is the magic trick. This is how we translate our imprecise, descriptive human language into something a machine can actually work with. It's the bridge that connects our words to the computer's cold, hard calculations.
And these are perfect examples of what I mean. We don't usually say the temperature is exactly 23.1 degrees Celsius. We just say it's warm. Fuzzy logic gives a machine a way to understand what warm actually means, as a range of values, and even how that idea of warm kind of overlaps with cool or very hot.
So let's make this super practical. A smart thermostat in your house doesn't need to know the exact temperature down to the decimal. It can just sense that, yeah, it's slightly warm. Then it applies a simple human-like rule. If it's warm, then turn the fan to medium. And boom, it produces a totally sensible action. That's approximate reasoning live in action.
So, where does all this fit into the bigger picture? Well, fuzzy logic has become this absolutely crucial piece of AI's modern toolkit for dealing with uncertainty.
Fuzzy logic is a real powerhouse for a few key jobs in AI. It helps systems make those smart, educated guesses from messy data. It's great at finding patterns in complex information, and maybe most importantly today, it helps us build AI systems where we can actually understand why a decision was made. It helps us move away from those scary, inscrutable black boxes.
But it's really important to remember it's not the only tool. It's more like one specialized instrument in a whole collection of methods designed to help AI make sense of our imperfect world. And often its true power is unlocked when you combine it with other tools in the kit.
And this is where things get really clever. You can hybridize these tools. For instance, something called rough set theory is great for classification, but it struggles with real-world numbers. Well, you add a dash of fuzzy logic and you get fuzzy rough sets, a much more powerful and flexible tool. It's all about combining strengths to create something even better.
So where is all of this heading? The quest to build machines that can handle uncertainty is far, far from over. Let's take a quick peek at the future of reasoning and what might lie just over the horizon.
Yeah, this field is not standing still, not by a long shot. Researchers are constantly cooking up even more sophisticated systems, things with wild names like fuzzy modal logic and fuzzy type theory that are pushing the absolute boundaries of what mathematical logic can even do.
And this might just be the most exciting frontier of all, quantum computing. See, a standard quantum bit, or qubit, can be a 0, a 1, or both at the same time. But a quiddit? Well, a quiddit can be in 3 or more states at once. That is a direct physical application of many valued logic, and it could open the door to unbelievable gains in computing power, all built on this fundamental idea of moving beyond just 1 or 0.
And all of this leaves us with one final, fascinating question to chew on. We are actively teaching machines to master the gray areas, the maybes, the sort ofs. So, if AI can truly conquer uncertainty, what on earth is the next frontier for intelligence itself?